Hey guys, this week BK and I are talking about hydration, which is an incredibly important topic for anyone that wants to stay alive and be healthy and also be a good athlete. So when we're talking about hydration, BK, what are we talking about? What does that actually mean?
Hydration, very basic, very simple, is the actual absorption and utilization of water, H2O. Super important. It's a big topic. We're going to do a part 1 and a part 2, a nutshell, and then more in-depth information. So hydration is using the water that you consume. Because, Rachel, how much water are you?
So, yes, I mean, I'm sure most people know this, but we are largely made up of water. Depending on your age, your muscle composition, we're around 45 to 75% water. And this is really important for our athletes to know. If you have a lot of lean muscle mass, which muscle is more water, right? 75%, fat's around 10 to 40%. So if you are an athlete with a lot of lean muscle mass, you are composed of a lot more water. So that's really important to keep in mind.
In part 2 of this conversation, we're going to go through, it's super fascinating to me, I'm a sciencey, geeky engineer, the different organs, the different systems contain more or less water, which is fascinating because basically, you could dumb it down and say you are water surrounded by water. So, and then if you think about it like that for a second, how do you get anything done? Your water bubbles surrounded by water bubbles, and how do you move stuff around? And this is what we mean by hydration. So this podcast / video lecture could be hydration / electrolyte 101 or 2, whatever. Electrolytes are stupid important. Like, you can't do anything without some of these electrolyte, magnesium, potassium, sodium,
right,
chloride. Anyway,
there's some big major players here, right? So when we talk about electrolytes, you have to have those, right? So one of the main things they do for us is they move the water around. Kind of like you were saying, we're like water surrounded by water, and we have to have those electrolytes to move us back and forth, move the water back and forth, in and out, right? So that's sort of how water and electrolytes work together. Do you have anything else to add to that? Was that a big review?
So for those that are a little more educated, and we're going to get into this in a lot more depth in part 2, she's talking about the sodium potassium pump. Okay. So it's a system in the body of a system of doorbells and doors where sodium, potassium, and the electrolytes, they either push buttons for water to move back and forth. So that's the kind of the sciencey geeky term, the sodium potassium pump, in order to do anything. Blink your eyes, pass gas, everything.
Right. They're what caused the magic to happen. And you mentioned that, we've got some major players: sodium, calcium, chloride. And then we've got some other really important ones like potassium, magnesium, phosphate. Some are on the inside of the cell, some are on the outside of the cell. And like you just said, those are what cause everything to go in and out and to make things happen in the body. Muscles contract, your heart to beat, which is a muscle, but yeah, definitely. So I guess we want to talk about the purpose, as far as purpose of water and electrolytes, and like, what does that do for our body?
Okay, so we have a list. Let's bounce back and forth like tennis on this list. Okay. So maintain, and again, part 2 will be a lot more geeky. Maintain concentrations of sodium, potassium, Your body requires percentages of all this stuff. Your blood has to be a certain way or you die. So water is so important in maintaining the concentration levels of all these different components that you need.
Yes, absolutely. And then the other thing we have on our list is blood volume. And, I actually did a study for one of my nutritional classes that was electrolytes and how they influence blood pressure, which blood volume plays a key in that. So lower blood volume is going to actually equal lower blood pressure. So we know that water, electrolytes, what we've got going on is going to affect our overall blood volume.
Okay. And let's just throw in there, if your blood management, all of that stuff is off, every single thing is going to be not working right. Okay. So the third thing on our list that we had was to move nutrients in, wastes out. Okay. So, think about, every single tiny little cell is a little energy center, and it needs to move things back and forth. Water and your electrolytes do that.
Yeah. And, if you think about that, just to add a little bit to that, blood is, depending on who you ask, 80 to 90% water, right? And that's what's transporting everything around in and out of those cells. And then we know that some of those nutrients getting in and out of the cells are really important to us, like glucose and amino acids. So that's part of that. Next on the list is blood pressure, which also is related to blood volume, right? So depending on how much blood volume we have and how much things are going on, that's going to affect blood pressure as far as hydration and electrolyte balance and all of that.
And just to interject, this is kind of jumping around a little bit, but for reals, runners, athletes, triathletes, all of this affects heart rate.
Yeah.
Like in your face. You want to, so, people are like, hey, my resting heart rate is too high because I'm overtraining. Well, maybe not. Maybe you're low on sodium. Maybe you're dehydrated. Maybe. So, okay.
Yeah, yeah, for sure. And then the other thing on our list is sodium concentration. And guys, I know this sounds kind of counterintuitive, but if you are a runner and you are not getting enough sodium, things are not going to function the way that they should. So, you've got to find a balance. So that's part of it.
Absolutely. And this topic gets a little unclear because FDA in, the past has said that, generally sodium kills, and let's say sodium, not salt. There's a lot of different salts, sodium, but recent studies, and we'll find the studies and we'll cite them in part 2. Studies are now showing that folks that are low in sodium have equally bad health conditions if as compared to having too much sodium. So it's common sense. We need to understand the principles and where we're at and how to get into the middle.
Yeah.
Okay.
And something that wasn't on our list, but it's so important. And I just, sometimes we just forget about it because it's so obvious, but water causes hydrolysis, which is what breaks down in our stomach, our fats, our amino acids, our carbohydrates. So we need that to break apart our food and for us to be able to utilize it. And something else I also just thought of is acid-base balance. So water is huge for that too, right? And we just have this little narrow pH range that our body can be in. So we've got to have water that can either lower or raise your acid levels.
Absolutely. And, one other thing that's kind of a byproduct or not direct purpose, but like runners, athletes, water and sodium going to keep you cool and not melt your brain. And water and this appropriate electrolyte hydration management is how you keep your kidneys healthy. And, most people say that, the ultra running, the marathons, the Ironman, it's crazy. However, if you do understand these concepts and do them well, sometimes they're not as terrible as what some people make them out to be, because you're not completely empty on some of the fundamental things that we need. I mean, I get done with a long training day, and if I get my Egg McMuffin, sweet tea, and my electrolytes are right, I'm feeling pretty good if I plan.
Yeah.
I am
killing me over here.
Sorry. Okay.
So kind of moving on from that, like how much water does each person need? And then how do we figure that out?
I was kind of hoping to get what you think, expert. You have all the letters with the nutrition stuff.
Sure. You know what? I like to keep it simple. And the easiest way to do that, now you can go in and you can have tests done, but of course everything's going to vary and fluctuate. I'm like, urine color is the easiest thing to do. So if you are peeing completely clear, you are overhydrating, right? And if you're going in and your urine is way too dark, then you are obviously dehydrated. You need that kind of light yellow color somewhere in the middle. And I will say, if you take B vitamins, sometimes that can skew colors. You might have fluorescent yellow pee, but you know, towards the end of the day, you should be able to see that. And I really like people to remember, it's not just soups, broths. Those are hydrating foods, and they're going to make that urine the correct color.
Okay, awesome. So, you know, I wanted to ask you a question. We'll just stick it in part 2 of what that yellow color actually is.
Oh, yeah.
Absolutely. And I know that you say keep it simple like that, but some people are numbers people. So if you were to do, like, what is it, ounces?
Oh, like if I were just saying how much fluid, you know, the standard formula is half your weight in ounces. So half of your, you know, if you weigh 150, you would drink 75 ounces of fluids a day. It doesn't necessarily mean you have to get a 75-ounce bottle of water, right? That still includes your soups, your broths, your herbal teas. You know, it includes the whole gamut of things.
So we're going to get more in depth into this in part 2 because it's a long conversation and everybody's a little bit different. But I want to interject in here. I have this conversation with all of my athletes. When you're doing the longer stuff, you need to put more thought into it because you're sweating more, you're doing more, you're pushing the limits more, you have less room to get things wrong. So the whole point of this conversation when we're talking about hydration is not just drinking water. Mm-hmm. We're talking about how to get your electrolytes in as well, okay? And mostly we're talking about sodium. I eat really clean. I don't, well, short of the Egg McMuffins.
You know,
it mixes me right up, like right. Anyway,
well, I did want to add something to that. And when I'm saying, you know, half your weight, you know, in ounces, that's of course kind of what you brought up with like athletes and training. I'm like, if you're out sweating for hours, and of course that's going to change your fluid needs. So sorry, just want to clarify that.
Right. No, that's absolutely true. We'll touch on that here in a second. So I have this conversation, and feel free, Rachel, to interject. I have this conversation with my people all the time. So if you're dehydrated and you go to the hospital, they are going to give you a saline drip that is 1% generally. What does that actually mean? 1%. 1%. So let's assume this is, you know, like a liter. It's not, it's a little bit less. 1% means that per each bike bottle that you drink, you need roughly 1,000 milligrams of sodium to change that into 1%.
Yeah, there's no, I mean, think about it. They would never go and give you they're not going to give you an IV drip of water. Right.
And it's buffered and it has some of the other electrolytes in it too. But the point that we're trying to make is for those people that are drinking way too much straight free water, you need to start researching and looking into how do I replace my electrolytes. And frankly, most of the solutions that I know about are insufficient in numbers. So like Noon might have 100, 200, maybe 300 milligrams of sodium per serving or bottle. So you're getting like a third of what you need to get it to 1%. And that means that when you're drinking a solution of something and it's a third of what you're actually made as, you're going to get behind.
Mm-hmm. Yeah. Especially, you know, and there's so many other variables too, thinking about, you know, your own sweat rate and
yes,
heat and all of those things. Yeah, for sure.
So that's why it's complicated. That's why there's going to be a part 1 and a part 2. there's going to be kind of like an article so you can see the numbers and understand everybody's a little different, but don't freak out, fret, or whatever, because there are easy ways to manage it. You just need to understand that you need to put some thought into it, and it's not just drinking a whole bunch of free water because you're not distilled water inside.
No, and that's actually really dangerous. I mean, that's how you end up with hyponatremia, right? If you're out training or running or racing and you're just guzzling down the water, I mean, that's a thing, and it happens to people, and it's super dangerous. If your cells swell too much because, too much water, and our cells in our brain, they don't have anywhere to go. Our brain is enclosed. So if that happens, it can be really, really dangerous.
So the description of that in layman's terms, when she's saying the cells swell and stuff like that, we go back to the H2O, the free water, the electrolytes conversation, and the sodium potassium pump. Okay. If you don't have enough sodium available, the water can't get moved into the cell. There's the whole mechanism is off. And so what the body does is it puts all of that water you're guzzling down into interstitial space, not the cells, right? Not your blood, etc. So you get the puffy fingers and the sloshy belly and just the looking fat, pregnant, right? I think the biggest problem is the blood volume concentration that goes sideways. Heart rate escalates, all kinds of things happen. But I think the biggest problem, Rachel, and let me know if you think differently, it's the brain inside the contained, the helmet. Okay.
Right.
So, the brain needs water. It needs to be cooled off. When the water goes into space that's not designed to in the head, then you basically squish your head, and it's very similar to concussion. And so that's when we get the cognitive issues to start off with. I mean, low sodium starts off with performance issues, but that's the big problem with this not getting the sodium right, is we're actually damaging our brain.
Right. And, and we keep saying sodium because it's such a major player, but I mean, obviously we're talking chloride and potassium, and
right.
I mean, they all play an important role. So yeah. But because we are talking sodium, which salt is composed of sodium, I thought this is just like a fun nerdy fact, but do you guys know that the word salt comes from, it's a Latin word, salarium, right? Or sorry, I totally screwed that up. The word salary comes from salarium. And that was basically because in ancient Rome, it was the amount of money they were allotted to the soldiers to buy salt, which was like one of their really essential but expensive commodities. So I'm like, even back in ancient Roman times, they knew salt is so important. I hope that made sense, because I think I screwed it up.
No, it did. It totally did. That's awesome. So you're absolutely right. And I think this is the reason why we are talking about sodium right now in this context. We'll cover some of the other ones too here in a second.
Hey, BK, before I forget, so for next time, I would also like to talk about how caffeine affects sodium levels. That would be in take 2.
Perfect. I love it. Yeah. Sodium intake is super duper important when you're exercising. That's when you can ingest sodium. You need it kind of, as you're going on. So, triathlon or long running, you're constantly sweating. If you're finishing your runs and you have salt all over your face and you have the white lines on your pants, you're getting it way wrong. Way wrong. So talking about sodium for runners and athletes and whatnot, you need to be ingesting sodium during. So like base salts, infinite, or the appropriate, do the math. Don't take your education from products, people. Seriously. Be smart.
Yes.
Do the math. It doesn't have to be expensive. Okay. You don't need to spend freaking $50 for these little containers of stuff to put inadequate amounts of electrolytes in your water. You don't.
No. And you know, actually, if I think about it, if I remember, I have a recipe, like a homemade recipe that people have great results with. I will try to remember to post that for the group. There was something else I wanted to say about that.
We will totally do that, because we're going to do a kind of like all of this rundown in an article so you can see it as well. The way I coach my folks is on magnesium. Magnesium needs to be eaten, and it needs to be in pill. You're not going to get enough magnesium from your food anymore. You need to take a pill.
Yeah, I'd actually like to interject on that. For my clinical nutrition applications class, I had to sit and observe in a doctor's office for an entire day. There were probably about 8 people that came in that were tested for magnesium deficiency. Every single one of them was deficient. It's a really common problem. Yeah.
It is.
Yeah.
I've talked to, I did that podcast on magnesium with the guy that was working at NASA at the time. We were talking about heat training and endurance. He's an ultra runner. And then just various other people I've talked to over the years, every single one of them agree, we are magnesium deficient. Everybody is.
Yeah.
The problem comes up is when we're pushing it. On our health assessment, we ask, do you sweat a lot? So if you're a person that's sweating, okay, that's a problem. Sweating a lot, so you're losing all these electrolytes. You're further depleting magnesium. Magnesium needs to be taken as a supplement. You are not going to get ahead of the game, but you can't eat enough leafy greens if you are growing them yourself to counteract this wave. You just cannot. It's not possible.
Yeah, it's pretty hard to get an adequate amount in the diet.
And if you look at the list, and this is how I look at it, Rachel, if you look at the list of health problems that come up being low in magnesium, you would never, ever even, you'd be like, oh, okay, yeah, don't need that. Restless legs is a pretty big indication of low in magnesium. Magnesium and potassium turn things off. Sodium chloride in general turn things on. Magnesium turn things off. So if you're a swimmer and your feet are cramping in the water, you don't need more salt. You need more of the things that turn things off, and that's magnesium and potassium. Heart arrhythmias. What else? The adrenals really need magnesium.
Even just insomnia sometimes. I mean, it's such a basic thing, but that can really help a lot of people.
Right. And your skin is fat. So if you want magnesium, don't sit in the bathtub to absorb it. I mean, while Epsom salts are pretty nice and everything, don't look at a bath as your source of magnesium.
Yeah, I mean, you're still going to absorb some. It's just not going to be necessarily at the level that you probably need it.
Right. In part 2, we're going to talk about, when you're low, and I'm going to try to find a smarty doctor person, hopefully that can write something up as far as blood test, calcium. You can't test adequate amounts of calcium with blood testing anymore. And I think that magnesium falls in that realm too. We're just not smart enough to.
Well, I mean, because most of it's in your bones and your tissue and stuff. Now you can do a red blood cell test, which is the best they have right now.
Right.
But yeah, I mean, it's hard to test for magnesium. That's true.
Okay. So sodium while you're exercising and then eating, like I salt everything.
And it's interesting, when you eat like dark leafy greens that are high in potassium, you tend to want to salt them. And that's actually a really healthy complement. It's like makes it kind of the perfect combination.
Right. Yeah, because Mother Nature had it right. They're all supposed to go together. So like I love salted nuts and the avocado with salt. And
yeah. And actually I should just mention too, and I'm sure we're thinking it, but we just didn't say it. When we're talking, I mean, when I'm telling people eat salt. Don't be afraid of salt. I'm not talking about the refined salt that has been heated to 1200 degrees and they've added dextrose to and anti-caking agents. I'm talking about like a Himalayan salt or a Celtic, although some people call it Celtic. I'm like, Boston Celtics, Celtic sea salt. But anyway, I'm talking about an unrefined salt with trace minerals, you know, because nature did have it right. Like it has all these things, and there's probably things in it we don't even know about that work together synergistically. Yeah.
So the product, the base salts, a lot of triathletes use it. It's very popular. It's just Himalayan sea salt, people, in a beautiful plastic tube. So.
Hey, and that if that's what gets people to use it.
I know. I'm like, for real, they're making a killing on.
Oh, why didn't we think of this?
Exactly, right. Okay, so potassium is important, but you have to be careful with potassium because it's not. So when you're taking magnesium, you know, you need to get something that ends in an 8, ATE, to be bioavailable for you. So citrate, etc. And then in my experience individually, people absorb it better brand to brand. You might need 2 different brands in the house, possibly for 2 different athletes. And that's kind of the downside, but it's the truth.
Well, just talking about, yeah, because different magnesiums have different absorption. So like a magnesium oxide, you're going to absorb like 4%-ish. If you get a chelated, so glycinate or whatever, and chelated, it means claw. It's got that amino acid wrapped around it. It's going to help with absorption. There's another, I don't want to throw brands out or anything, but there's another one that's like pico size that is incredibly high rate of absorption. So if you can look for something like that, that's good too.
Yeah. Most of the available supplements in a store are going to be the cheaper magnesium oxide, which is mostly just a laxative. I'm on the phone. Thank you. So magnesium cake. He asked me about cake.
What, is there anything else you need to tell me? Egg McMuffin, cake? No, I'm teasing.
Hi, my name is BK. I like food.
Yeah.
It's also his birthday.
Oh, well, that's a good time to have cake, actually.
I know, right? So magnesium on all of this stuff, a big point that we're saying is pick up the bottle and look at the back.
Mm-hmm.
Don't know, ask us. Send us a picture. You need to look at the ingredients, not just take their advertising and their marketing to heart. You need to look at the back on all of these things. So the right kind of magnesium, bioavailable, not super duper. Dude, out of the kitchen for 10 minutes now, please. I was very clear when I asked you to stay in there. You totally need to edit that out.
We'll give it enough pause time.
Okay, so magnesium, the right kind, look at the back, and then just understand. I think in part 2, Rachel, let's go through and say kind of some biofeedback that you can have on if you know that it's working for you or not. Like if you have restless legs. Yeah. Okay. Yeah, so that would be good. We'll cover that in part 2, so that you know if the brand that you're using is actually, working for you or not. Okay.
So kind of moving on, do we want to move on to long race, like considerations or issues that can arise based off of that imbalance of
Let's, I want to interject one thing. If you guys have questions about some of the stuff that we're asking so far and we haven't covered it, message us or email us, let us know your questions and we'll include those answers in part 2. There's some other nitty gritty stuff that we want to cover, like, there is a percentage of the population that is sodium sensitive and whatnot. So, we just need to be educated. And if we are wanting to do long distance, crazy, epic stuff, we need to understand some of this stuff and get fundamentals and kind of understand and experiment and train consistently so you know what you're doing.
Yes, that's an excellent point, because there are populations that definitely are sodium sensitive, and even some people are reverse responders to sodium. So you need to, and that goes back to like kind of doing your own research and being your best advocate for your health. Sorry, I don't know, I can't talk today.
You didn't have an Egg McMuffin?
That's next time I will start with an Egg McMuffin. So
Okay.
long range, kind of some things that we want to just touch on them today and maybe go a little more in depth next time, or do we want to just throw it out there that these are some things?
Let's give them enough idea to get started with, and we'll definitely touch on, we've talked some of this stuff already, but yeah, we'll get an overview, and then part 2 we'll go over it a lot more.
Okay. So we've got water absorption, which we really did talk a lot about. You got to have the electrolytes to move water in and out of the cells.
What do you recommend? So runners, what do you recommend as far as when they're exercising? How much H2O, how much fluid are they needing per hour?
Well, you can do, and it varies individual to individual. So that's so specific for people. But, a lot of times they tell you to do the weigh yourself, run, weigh yourself. What's the difference? How much fluid did you lose? You're not going to replace all of that while you're running. Sometimes that's, it's overkill. You replace some of it when you're finished, but it's going to depend. So again, case by case basis.
Yeah. And I just this will be part 2, but something to think about, Rachel. And I asked this a bit. Wonder if we can get a smarty that does this stuff. If you're low in sodium, you're not going to be sweating as much as if you weren't low.
Mm-hmm. Yeah, there's a lot of things that we learn about sodium that a lot of new research is saying maybe we got it wrong. So it's definitely something to think about. And I have a person in mind that I would really like to get us to be able to talk to.
Yeah. Something else interesting, maybe we'll touch on in part 2, as well as studying in this hormonal class that I'm in right now, and completely touched on the fact that if your hormonal health is off, which will affect your endocrine system, which will affect your kidneys, which will affect your management of sodium.
Mm-hmm. Yeah, it's all tied together. So yeah.
So we went on a bunny trail. I tell my athletes, like if they're biking, to drink one of these an hour. About 700 milligrams. Bike bottle an hour. It does pretty well.
Well, and so then, okay, so yep, we kind of covered that. Belly osmolality. You want me to touch on that, or do you want to touch on that, or?
Yeah, let's hear what you got to say.
Well, it's just something that we really need to think about is, if you're taking in too much and your body's having to pull water out of other, it's going to have to pull that water in to digest it, then your working muscles and things are going to suffer. So you've got to find a balance with this.
Absolutely. And osmolarity kind of talks about the movement, means the movement of the water. And so, getting the electrolyte balance is critical. So it, moves back and forth, or like people, you can't stock up on electrolytes. Okay. They just need to be topped off, and then you need to do it right each hour, by effort, by how much you're sweating. You can't dump in a massive amount of sodium into your belly and think that it's going to work right.
Well, and then you're going to get thirsty, and you're going to need a bunch of water, which is fine, but it's going to be, like, when it's not spaced out, that really doesn't feel so great.
Right.
Yeah.
Okay. So too much water, sausage fingers. We talked about that. That's the water getting put where it's not supposed to be.
Mm-hmm. Mm-hmm. Cardiac drift, cardiac creep. Do you want to, we can touch on that today.
Yeah, we'll talk more about it in part 2. So cardiac creep, drift or two different things in the Smarty heart rate training world. But basically we're talking about the heart rate creeping up for various reasons. Being dehydrated, meaning you're either getting the H2O sodium relationship wrong, or you're not drinking enough water, etc. I mean, because you can kind of get symptoms of being dehydrated by not having enough sodium because you're not using the water. That makes sense?
Yeah, the symptom, yeah. Mm-hmm.
So, you're drinking more water. And just an example of this, the first half Ironman that I did was in Kansas, and it was hot, and it was an SOB, and it was hot. And I was getting it wrong, way wrong. And so the volunteers were saying, drink more water. And I was probably in a state of, the hypernatremia. And then drinking more water is going to make it worse. So, if we're doing these things, marathoning and stuff like that, we really need to be responsible for ourselves and understand what all of this stuff is, and don't poo-poo it like, oh, that doesn't happen. It happens all the time. It's super duper common. And then we're stubborn and kind of a little uneducated and stubborn. And we think that things are supposed to suck. So we just go ahead and bear down and force ourselves through it, when sometimes your body is giving you an indication that you are getting it way, way, way wrong.
I mean, and there have definitely been cases of athletes that they get it so wrong that it results in death.
Absolutely. And that race in particular, I actually ended up in the doctor's office the next day with acute renal failure because I got it that wrong. Yeah. So it's not uncommon. It's just the various stages of it and how well you deal with it and how well you don't.
Mm-hmm.
So we'll talk more about some of that stuff, more technical terms. We already touched on kidney health. Talk to us about hydrating before long races.
Well, and again, this just goes back to, it's not just water, right? And one of the best strategies you can use to kind of play it safe for hydrating before long races, soups are amazing, broths are amazing. Water is good, and that's fine, but when you do the soups and the broths, you're naturally getting all those electrolytes that you need along with it. So for anyone that's ever done a really long, a 50K or 50 miler or 100 miler, they could probably tell you broth is a game changer for people.
Oh, yes.
Yeah. So it's important to just keep those kind of things in mind, as you are trying to stay hydrated before the race. And you need to, it's just as important to hydrate after the race if you want to bounce back quickly.
Absolutely. In Ironman training, they'll say I felt decent after, and then they feel like dog poo for 3 or 4 weeks or whatever. And I'm like, well, how well did you eat after? How well did you maintain your fueling and your nutrition after? Oh, I didn't.
Yeah.
Okay. Okay.
Well, that might be an indication of why that happened.
Because when you get low in electrolytes and you get low in sugar and you get low in all this stuff, the body, it's like you've been in, out in the wilderness starving.
Mm-hmm.
Wow. Okay.
Yeah.
Next time we'll talk about, signs of being low in, calories versus what it feels like to be low in sodium versus what it feels like to be low in magnesium. There are some biofeedback signs on that. Cramping is, kind of a general one, restless legs. I ask my people all the time what they are craving. If someone's craving chips.
Yeah.
That's sodium.
That's a pretty common thing for an endurance athlete to crave.
Devour the chips or French fries, right?
Mm-hmm. Mm-hmm.
Okay.
Yeah.
What else do you want to talk about?
I think we should probably wrap up with that, and then we'll everything we said we were gonna go in more depth, we will follow up with the
Okay.
next video details on all of that. And fingers crossed, I can also get this really amazing expert to maybe talk to us a little bit about sodium. We'll see what happens.
That would be excellent. Okay, if you have any questions, just get with us and we will make sure that those questions are answered in part 2 as well. So thank you. Have a good day, people.
Ciao.